As a further look at C-mode behavior inside the cell matrix, let's consider this case. Again, we have a source cell with a truth table that we presumably consider to be interesting, and we have a controller sitting next to it, which places a 1 into the source cell's C input. The source cell is now in C mode. Its data output goes into the controller. The controller recirculates it back in so that there's no change to the source cell's truth table. The controller also sends this through a series of cells to the west, and the number's not important here, but we can imagine this to be perhaps a very long line of cells. And then somewhere over here on the far west, we have a new cell which we consider to be the target. We send a 1 into that cell's C input. The data from the source cell's truth table, the data lines carry the bits from that source cell through this controller all the way over to here and into the target. And so after 128 clock ticks, the controller will have read this cell's truth table non-destructively and sent it all the way over to the target, which is now an exact copy of the source cell. And so this is a non-adjacent cell replication. We've made a copy of this cell at some remote location, and in this case 4 cells away from the source cell. So cell replications and copies and writes do not need to be adjacent to the source cell. They can occur at a distance, and in fact they can occur at a very great distance. Now this is all fine, but so far all of these circuits have been particularly configured to do the kinds of operations that I'm describing, and that's really all they ever do. We're constantly copying the bits from the source cell to the target cell, and that's not particularly useful because at some point you would like the target cell to leave C mode and go into D mode so we can actually start using it. So let's look at a more realistic example of how we might use some of these features. So here's our source cell, and I'm just going to draw some cells next to it. And in this case, I'm going to control the replication operation from an input to the north of, let's just say, this cell here in the middle. So I'm going to feed a signal in called go. And go is going to do a few things. First of all, I'm going to, for simplicity, just assume that these bits are copied to the west. And what I'm going to do is I'm going to show another line of cells below here. Because remember, these cells are sitting inside a presumably large matrix of these regularly tiled blocks. So I'm going to use my go signal to do a few things. One, I'm going to send it over into this cell's D input. But here I'm going to take that D input and transfer it to the C output and send that into the C input of the source cell. So the truth table in this cell would be something like control east output equals the data west input. So now if I set the go line to 1, this cell goes into C mode. If I leave go at 0, this cell is operating in D mode. Additionally, I'm going to take this go signal and I'm going to send it into this cell to the south. And I'm going to send that over here. And in this cell, I'm going to send it up like this. And then inside this cell, I'm going to connect that to the C output so that it feeds the C input of this target cell. And now we have an interesting behavior. Whatever's coming out of the source cell's D output is always being sent into the target cell's D input. That's just for convenience right now. But the go input is not only placing the source cell into C mode, but if go is equal to 1, that 1 will come down here to the south, move to the west, move back to the north, and then this cell has a truth table like control west equals data south. So whatever comes in on the data south is sent to the control west output. So when the go line is asserted, this cell is placed into C mode. And now by turning on the go line, the source cell is copied into the target cell. After 128 clock ticks, I can turn off the go line, and now I've got a clone of my source cell over here, which we could again begin using at that point. In a more sophisticated, slightly more sophisticated version of this, we would break this data line between the source and the target based on the value of the go line, presumably if we wanted to do something with all 4 inputs on the target cell. But that's just an embellishment. That's just standard digital logic. Nothing magic going on with that. So here's an example of cell replication that can be turned on or off via a digital input to the top of one cell. And there's nothing magic about this particular arrangement. There's a lot of ways you can arrange cells to achieve the same thing. This is just one example.